This question involves the sampling of a television signal. So it's a high-frequency signal, 4.5 megahertz, and we're digitizing that. So we're sampling, then quantizing. So the first question asks for the sampling rate, and it's only slightly oversampled, so it's 20% above the Nyquist rate. So if the sampling rate is 20% above the Nyquist rate, so that's like 1.2 multiplied by the Nyquist rate. And the Nyquist rate is simply twice the highest frequency. The highest frequency is given with the bandwidth of the message, so it's 4.5 times 10 to the power 6. So again, 1.2, that's the 20% above. The 2 comes from the Nyquist rate, and the 4.5 is your bandwidth. So that gives you 10.2, let's just say megahertz. The second question is to find the number of bits required to encode each sample. So that's basically finding n. And n is related directly to the number of levels. We don't have many levels in this case, it's 1,000 levels. So it's simply log to the base 2 of 1,024, which happens to be 10 bits. So not a large number of bits. And then it says how many bits do we need to encode a 10-minute television segment. So the total number of bits is determined by 3 things: the number of bits per sample, the number of samples per second, and the total time, so the total number of seconds. So in this case it's 10 multiplied by 10.2 megahertz, so times 10 to the power 6, multiplied by t, which is simply 10. But because it's 10 minutes, you need to multiply by 60. That will give you 7.2 times 10 to the power 9 bits. So that's how many bits you would need, and that is your final answer.